understand what's happening. And then now I'm going to get some formulas, most of which you can find on, say, Wikipedia. But the way we're going to do this is we're going to understand its action. And I said here on the blocks, I really want to think about them as actually on the little facets of each of the blocks. So I have two different structures that I can see here. First of all, there are different kinds of pieces. I'm saying these are like really stupid and really obvious. Namely, they're the center pieces, they're the edge pieces, and they're the corner pieces. Well, I've said they're different. Why are they different? How do I know that they're actually different? Well, first of all, we actually already answered this one. So I'll ask now, can any move in the group send an edge piece to a corner piece? I'm seeing a lot of people shaking their heads now. Why? Edges have to go to edges, yes, but that's a statement of why can't they go to corners.
Corner pieces have 3 colors and edges only have 2.
Corner pieces have 3 colors on them, edges only have 2. Exactly. So there's that, we've picked out an invariant that's showing up. Namely, the number of colors that a piece has isn't going to change by moving its location around. Edge pieces have 2, corner pieces have 3, middle pieces have 1. And we know that the middle pieces actually, I mean, I could have done that sort of middle move, but I'm always fixing my orientation in space. So the middle pieces, I can assume, aren't actually moved at all. So now I ask, well, we already answered this one. It doesn't say edges to corners. And the last one is, can I move the corners or edges around willy-nilly? This is a much more subtle question. So there's 2 parts in that. Could I take this corner and imagine pulling it out, twisting it by 1/3, and putting it back? So that's one thing I could do. I could twist individual corners. Or I could say, can I take this corner and swap them? And if I could do either of those, then I could actually completely rearrange the corners any way I wanted. And we'll come back to exactly why in a minute. And the answer to that is, seriously, Google? Seriously? It's, the answer to that is almost. In fact, it's almost on the page. You can almost see that you almost that you can almost do it. So what do I mean by that? Well, let's first figure out if we can swap corners. And I've written a sequence of moves, so let's see if I can do it this time. So I'm supposed to do the inverse of my right move. Well, there's 2 ways I can do that. So I'll just orient it so that you're looking at the right face now. So this is my right move. It's the first move. It's a quarter turn clockwise. There's 2 ways I can realize the inverse. I can either say, do the quarter turn counterclockwise. So I have good spatial reasoning here. Or I could say, do my clockwise move 3 times. And if I do my clockwise move once more, I'm back to where I started. So in other words, I'm already seeing that my fixed initial moves, R, D, blah, 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 they all sit inside this as a little group of order 4. It's that same sort of arithmetic mod 4 that we saw. I can do it, but when I do it 4 times, I'm back where I started. Okay, so let's try this. I want to do the inverse of R, the inverse of D, R, D, and this is a crap, so I actually have to keep doing it. Inverse of R, inverse of D, R, D, inverse of R, inverse of D, R, D. If we look at it from this side, this is the white face, and this is the green face. But these 2 are not in the right locations. And in fact, if I look at the other sides, this is the top. So I see this should be the red side, but here it is. It's actually taken these 2 corner pieces and it's flipped them. So I can do that. You say I had to do this R inverse D inverse R D. I had to do it 3 times to get to this position, and that one I had to keep oriented a little differently. But I also swapped 2 others. So I could swap 2 corners arbitrarily at the expense of also swapping 2 other corners. So I can't just do two of them, but I can swap two distinct pairs of them. So that'll come up again. So I can also permute edges around. Actually, it's not hard to see, and we might come back to this, that if I can swap two pairs of things, then I can also create something that just cyclically permutes three of them. You imagine that you swap two of them, and then the other two that you're going to swap happen to share a fixed edge. So let's try and permute them. These I'm not going to try and demonstrate, because there's about a 99% chance I'd screw up at some point and be irreparably lost. So you can imagine you have this string of moves that you're supposed to do, and you have to do it. The outer square says this whole thing on the inside, which you should do twice. And then what's it give you? Well, here's what the cube looks like if I'm looking at it in the standard orientation I've been doing. So the white's going to be coming forward. You see that this piece, which should have been at the very top right, is now on the white side. And then if I rotate it around so that now I see the other side, I see the white piece that was there has moved on to the yellow side. The yellow side has moved on to the green side, and the green side moved on to the white. So it just rotated those three around. So I could rotate three of these, but I can't swap two edges. And in fact, same thing I did before, I could swap two pairs of edges, just like I could swap two pairs of corners. Now let's figure out the rotation of the corners parts. It gets even worse. Here you go, you can try it. But I'll just show you, because actually they're frighteningly long to take these photos. So you see, this same orientation, except now it's on its side, but the red face moved on to the white, moved on to the blue, moved on to the red. So I did a rotation that would be like that. On the other hand, you can see in the back that back square is not blue anymore, it's orange. And in fact, I don't know why the camera did this. This is the yellow one, that's the orange one at the top, and then there's blue. So this one I rotated like this. This one I rotated like that. So I couldn't just do a rotation, I had to do two rotations, and the two rotations were opposites of each other. I couldn't just rotate one in sort of a nice 120-degree rotation. One, I did a 120-degree rotation. The other, I did a 240-degree rotation, or a minus 120-degree rotation. So you can think about it as, I can imagine that the corners themselves are then in some sort of fixed position, and I assign numbers, namely numbers mod 3 to the whole thing, saying, am I in my position? Have I rotated once? Have I rotated twice? Am I back to where I started from? So that's another example of my modular arithmetic that we saw. And what I'm supposed to do is, if I change it, I can change one by one, but then I have to change the other by minus one, or some other by minus one. So it might not be that the numbers are the same, but the sum of all of the numbers has to stay the same. So there's another little invariant that we find. And you can do the same thing for pairs of edges. I can't flip a single edge, so namely swap. I couldn't take this one and just sort of swap it without on some other edge also swapping.